Hello, EFR 515 students. Today we're dealing with Chapter 7, Probability and Sampling, the Distribution of Sample Means. And this is a very important chapter for us that continues on our understanding of theoretical distributions or density functions like the normal curve where we make decisions on. And so we're introduced to the idea of sampling error, sampling populations, and then distribution of sampling means. And the key concept here is that we are actually going to make decisions based on our probabilities based off the distribution of the means, or what's called the standard error, instead of the standard deviation of the observations. So really try to read and understand that issue in the chapter. They talk about the central limit theorem, that is the theory that underlies this, but we're really after this concept of standard error and the definition, for example, on page 207. Critical to our deep understanding of what statistics is and the difference between the standard error and the standard deviation. And they show some of the formulas for it. A very important formula for us is 7.1, for example, on page 208. And then what happens, for example, the standard error and the sample size in table 7.2 on page 209. These are very important concepts for us in the probability of sampling distributions and alike. So again, you're really trying to understand what standard error is and its relationship to standard deviation. On page 214 in box 7.2, that's very important for us. The formulas there, you should know those. In fact, if I asked you what's the formula for standard error, you should be able to write that formula and understand what's happening with sample size. As sample size increases, the decisions we make, how standard error can become smaller in that sense. So we're just going to do a little simulation exercise based on standard error and standard deviation for this assignment. So I say simulate 10 variables of random normal numbers and calculate the mean and standard deviation of each one. Then enter the means of each variable and calculate the mean and standard deviation, which is then the standard error, and make a histogram of the means. Superimpose the normal curve. So in essence is we're taking observations, we're taking their means, and then we're creating a distribution of the means. And that's in effect what our standard error is. It's a distribution or the dispersion of the means of observations in the central tendency idea and the central limit theorem. So let's go ahead and do that. You'll need to open your SPSS. So I'm going to go ahead and I'm open over here. Because we're going to be starting with the syntax I gave you, you'll need to go to File, New, Syntax, and go ahead and open a syntax window. Okay, so here's our window, and I'll go ahead and get the code from the assignment. So I'm just copying the code. Be careful not to copy what I said, the sample code, or please place your syntax, etc., etc. So I'm going to go ahead and copy this over to my syntax window. I'm going to paste it in there. Okay, so now that I'm pasted in, I'm going to go ahead and block. So I'm going to go click on my left side of my mouse, I'm going to drag it across, and then I'm going to run it. Okay, and what this did for us is it created 10 variables, x1 through x10. We asked it to create 20 observations in each, and these are all based on the standard normal distribution. So we know the standard normal, in theory, has a mean of 0 and a standard deviation of 1. Because we just have 20 observations or a sample from that, we don't expect it to be exactly that in our sample. But in the population, we expect, again, to have a mean of 0 and a standard deviation of 1, because we have a z distribution or a standard normal distribution in that. So here's our individual observations. What I asked you to do is then plot a histogram of the means of each one of these. Well, when we ran this in the code, in the output window, we got our table here, and here are the means I'm asking you to plot. So just click on this table and copy this table over into your Word document. Okay, from there, we're just going to go ahead and block and copy that. We can do it if we're just in Word. You could retype these into the Excel or SPSS program. I'm just copying. Again, I'm just going to drag. I'm going to block the observations. I'm going to press copy, and I'm going to copy. Now I'm going to go back over to SPSS into the data editor. At the end of the file, I'm just going to go ahead and paste that in there. And here are the means of all these observations. So I'm going to go down to the tab. Now again, remember there's two tabs at the bottom. There's variable view and data view. We can go to variable view and we're going to name this, and we're going to name it standard deviation of means. And then we're ready to go ahead and get a graph from that. So we go up to graphs, legacy, histogram. Okay, we have all the observations here, and then we have the means of that. So we're going to go ahead and bump that over. So we got for standard deviation of means, and we'll go ahead and display normal curve. Now this we're not expecting that this be very bell-shaped because we only have 10 observations. Then we'll go ahead and paste that. Because it's not the first time I've pasted something into the window, I have to go down to the tabs down below and find that. And here it is. I'm in Centex window. I'll go ahead and graph that. And we see in our graph. And again, we don't expect it to be very normally distributed, but if we continue to have observations, we would expect then the mean to be 0. And these are standard error, and depending on my sample size would be the degree of dispersion around that. So a bigger sample size, the distribution would be tighter. A smaller one, it's going to be farther out, and that's going to become the basis of statistical power that's talked about in the chapter. So then go ahead and just copy this in. Okay, so within the assignment, again, the code's the same, so you don't have to recopy the code, but you should have a table of the descriptive statistics and the means for each one of those, and that'll work just fine. And then go ahead and plot in your graph. Okay. All right. So if you're curious, you could go ahead and change the code and take it, for example, 1 to 100 here. So change this to 100 and this to 100, and redo this assignment, and you just see that bell shape come in a little differently. But for now, this is all I'm asking, that you go ahead and do it for 10. And read the chapter very carefully, and I want you to reflect on it, because this is kind of the basis of understanding and feeling comfortable with the testing that we're going to go on and do. So thank you so much. Go ahead and upload this, and you'll be all done.